It is important to understand what data types are available in LabVIEW and what values each data type can take on. Here we have the three most basic data types in LabVIEW: the Boolean, string, and numeric data types. The Boolean data type is represented by the color green and can take on one of two values, true or false. The string data type, represented by the color pink, is a combination of ASCII and non-ASCII characters and is typically used to store and display text. The numeric data type, represented here by the color orange for its representation type, takes on the value of a decimal number. A special data type in LabVIEW is the enum, which is composed of both strings and numerics. It is an enumerated list of string values. In other words, a list of string values where each string value has a number associated with it. We will go over how to compose an enum later on in this tutorial. While wiring a VI, it is also important to keep track of the order in which elements are wired and how this impacts the sequence of events that take place during execution. The data flow model is used in LabVIEW to determine this sequence of events. When determining data flow, there are two basic rules about the execution of a function or sub-VI. One is that the node executes only when data are available at all of its input terminals. The second is that a node only supplies data to its output terminals when it finishes execution. So following the data flow model, the piece of code here would execute the add function first, since its inputs are available as soon as the execution begins. The subtract function executes once the add function finishes execution, since one of its inputs depends on the resulting output of the add. We will now explore the concept of data flow further, as well as the data types we discussed, by examining a small sample VI. Here is the front panel of our example VI. On the left side of the front panel, it contains a Boolean control, as well as a Boolean indicator. These can both be found in the controls palette by right-clicking on the front panel and going to Modern, and then Boolean. To change the mechanical action of a Boolean control, we can right-click on it and go to Mechanical Action. These different mechanical actions determine the way that the control changes value when a user clicks on it. We will leave the action as switch when pressed for now. When we flip to the block diagram of this VI, observe that the Boolean control and indicator are both represented by the color green, as is the wire that connects the two. This is the color for all Boolean data types. Going back to the front panel, in the center, we can see that there is a string control a numeric control below it, and a numeric indicator just to the right. String controls and indicators are found on the Controls palette under Modern, String and Path. Numeric controls and indicators are also in the Controls palette under Modern, Numeric. In programming, numeric data can take on several different representation types. To change the representation type of a numeric control or indicator, right-click on it and go to Representation. We will change this number's representation to long.